To those who do the hard work, day after day, who don't do 9 to 5, who never know what the day may hold. To those who risk it all, who carry us when we can't walk, who run to face danger. They call you first responders. We see you as much more. For us at Darley, you're our inspiration. You've set the bar. You're our guiding light in all that we do. Your courage gives us our strength. Your sacrifice gives us our purpose. You have shown us the meaning of integrity, to act ethically, and to do what we say we are going to do. Your dedication has given us the passion to think of your needs first and to place service to you above all else. You have shown us the value of relationships built on trust and respect. Your family has taught ours the importance of teamwork and created a culture that empowers us to make decisions on what's right for you. Your selflessness fuels our drive to innovate new technologies and solutions that allow you to carry out your missions better, safer, and smarter. Your victories are our rewards, which we cherish and give us the greatest sense of satisfaction. For over 100 years, your example has shaped who we are. We are Darley. Trusted worldwide since
All right, everyone. Thank you. So we are just about 1 minute off schedule, which I could say is pretty darn good. And there's been some fire content so far. Thank you to everyone who has been here. So we are now moving on to the final event of the day before closing remarks from Eric. But this is aerial design cases with Jennifer Bloemer. I'm sorry if I pronounced that wrong. Justin Howell, John Brady, and Tom Shan. I am now going to spotlight the videos again for all the main speakers. 1 second here. Jennifer, hi Jennifer, hi Tom. 1 second. John. And last but not least, Justin. I believe it's 1, 2, 3, 4 of you. So I think we've got everyone else. Everyone else, I'm going to move you back to the audience. And Tom, take it away with the final event for the 45 minutes of aerial design cases. The floor is yours.
All right. Thank you very much, Kevin. Well, good afternoon, everyone, and welcome to Jennifer, John, and Justin. Going to cover the subject of aerial ladder design, some of the criteria that these engineers go through. If you look at some of the product developments over the course of the last couple of years, I won't tell you what year it was, but when I came into the fire service, an aerial ladder device didn't have any kind of weight rating. And if it was extended even 50% of the whatever the rated elevation was, and it happened to lift itself up, you were having a great day. All right, things have improved tremendously since that point. So our first topic is going to be for the manufacturers. Everyone's familiar in the audience with saying, well, it's got to meet NFPA 1901, you know, and that should take care of it. But what other standards that the industry typically follows, whether they're generally accepted practices or things that they're carved in stone? This is what some of the criteria that you have to follow. So Jennifer, we'll start with you. You want to rattle off a couple of them and how you view the importance of those impacting the aerial products that you work on and design?
Sure. Like you said, Tom, everything starts with NFPA 1901. That's the backbone of our design. Everything, there's several other standards referenced within 1901, such as there's other NFPA standards, 1983, 1989. There's which are breathing air. There's life rope rescue. There's also NFPA 70. That's for the electrical codes. Several other standards, of course, the AWS for American Welding Society, ANSI standards, ASTM for testing criteria. We can go on and on. There's several different standards that we will use in designing an aerial, as well as keeping up to date with some of those standards. They do get revised on occasion. So making sure that as a manufacturer, we're going out and making sure that we always have the latest standards. They do change on occasion, and they don't always tell you, come out and say that they've changed. So keeping an eye on the latest standards is definitely something that we do. But there's a lot of detail to get into each of those and how that affects the design and things, but several different standards that we'll look at.
Yeah, no, it's interesting when you mentioned about NFPA 1983, about the standard on life safety rope. It seems that of late, because many departments are utilizing their aerial devices for different aspects of technical rescue, low angle or high angle, that question comes up. A lot of times I find that final inspection, people, maybe the tech rescue person wasn't intimate with the design of the vehicle with the committee, but that person will come up and go, hey, I'm part of such and such county's tech rescue response unit. That's the aerial device that's going to come in on something in my battalion. And what are the ratings for all these different areas? So very good point. So with that, I realize you can't distill it just down to the three areas, but what are three major criteria that you need to look at to be able to define the tip load rating? It certainly got much easier years ago when the NFPA qualified that in 250-pound increments, that before people had devices that the manufacturer could rate them for what they felt they were capable of doing. So there was a off time where you had 400-pound tip load devices, 550. There was one, I think, that was 600 at the time. But John, what's, from your perspective, you've had a stellar career, to say the least, of looking at, designing a lot of different devices. What are some of the criteria that is important to you in looking at to determine, how the device can be rated?
Well, I think the first thing you need to consider is the end user, is how you're planning on using the aerial device. Are you planning on having a pre-piped waterway? So you need to account for locations for water weight, nozzle reactions, and so forth. So you need to realize how you're going to use it from a water perspective. The other thing you consider is offsets and horizontal reach. And are you planning on doing river rescue, below grade rescue? So now your tip load needs to be referenced on the weight of maybe one or two firefighters to tip a ladder, and then maybe a victim that you're going to try to rescue from a river car wreck below embankment. So you need to take into consideration the load you have on the ladder plus the load you might put on the ladder during like a rescue event. And part of the third criteria is, depending on your tip load and your reach and so forth, what kind of horizontal reach do you want or setup you need for your outriggers? Obviously, the longer the horizontal reach and the higher your tip load, the more your stabilizer spread will be. So if you're in an area where you have a very tight setup where outrigger spread is very important to you, that's important as far as identifying what tip loads and such that you want on horizontal reach and tip load to make sure you can set the truck up within the confines of the areas you have to set it up.
Right. So most people can assimilate the information between, or maybe not with the weight capacity, but if you were, to go around to a trade show and to be able to look at the difference in the massiveness, so to speak, of the device between a 250-pound tip load, a 500, and a 750-pound tip load. So Justin, in your background and experience in looking at working, hands-on with customers, what do you see as the level of discernment, or how do they determine, that they want, for example, it's pretty simple between a 250 and a 750, but when you get to the difference between a 500-pound tip load ladder and a 750-pound tip load ladder, from a pragmatic experience in the field, what do you see the questions that they'll put you through to determine which one, what type of device is going to be best for their application?
Yeah, so it's mainly determining what they want to do with the truck and the functionality that John was kind of alluding to as well is, are they looking at a mid-mount aerial or are they looking at a rear mount aerial? Each one has its own functions and its benefits over the other one. It all depends on, your tip load in different areas. So the way the truck can be set up, you really have to evaluate your community and know what structures you have, what kind of setback you have, what kind of reach you're looking at, whether you need a platform or a straight stick ladder. So there's a lot of variables that go into it from a customer standpoint of, do I need a single axle aerial? Do I need a tandem axle aerial? How much equipment am I going to offer or carry on the truck? What's the functionality? We have certain customers that run them like pumpers, and there's certain customers that run them like a rescue. And then we have certain customers that run them like a true ladder company that literally they don't want to pump, they don't want to tank. So all that has to come into effect when you're talking about the tip load and counterbalance. So there's a lot of factors from the design criteria that when you're determining the tip load, are you flowing water? Are you not flowing water? So each one of those does take into consideration of how you set up the aerial, whether it's short jacked on one side, like John was saying, the spread, the outrigger spread, how many outriggers you have, the placement of those outriggers. So there's a lot of engineering that definitely goes into the design of these aerials, and the way that each manufacturer offers it, they do have benefits over the other.
All right, thank you. So I've noted that in several different aerial manufacturers, their published specifications, if you're going to work with them to build a device for you, that within the specifications, they say that the unit will remain operational and stable under certain wind conditions and under certain ice load, build up conditions. If I'm down in Florida, I probably don't have to worry about ice buildup, but where I lived for 28 years, if you're living up in Syracuse, New York, you become very familiar with your aerials and your ground ladders icing over during the wintertime operations. Jennifer, what are some of the dynamic loads that you have to consider if you're, designing from scratch a device or things that that are critical to being able to determine a verified and validated weight load for that device?
Okay, so as far as looking at water flow, turning, starting the water, stopping the water, the amount of nozzle reaction force, what angles that you're going to allow. Some go 90 to the side at certain GPMs. That may decrease as you get further forward or up. As you go up, that may go, it really varies depending on what the criteria is that you're designing to. And a lot of that goes back to, we're trying to maximize the flow with the reach of things, but definitely taking in nozzle reaction forces to the ladder and all the different positions that you're allowing that device, whether it's fully extended horizontal or fully elevated, all the different conditions, you have to look at the nozzle reaction forces, as well as starting and stopping when you start that water flow. The wind loads too, at all different elevations. Wind speeds increase as you get higher. There's certain standards that we look at for like ASC standard for wind ratings and certain criteria that we use to develop what we design, how we design our aerials to handle different wind speeds. Just how the speeds of the aerial where you start and stop the system. Some aerials are direct hydraulic, some are electrically controlled, and you can start and stop the aerial at different speeds. How fast it starts, how fast it stops are dynamic loads that you have to take into consideration when you're looking at the design and test those afterwards as well. But that's primarily the speeds of the aerial, the water flow, nozzle reaction forces, and the wind loadings. Ice is more of a static loading. That's gonna, you'll derate your loads as you get more ice. A lot of, they say up to 1/4 inch of ice, I think is pretty typical that you see. And how that's determined, that's calculated in up front. Make sure that we can handle that at the rated loads that we specify in the ice charts.
Okay, thank you. So John, a question, Jennifer brought up a good point talking about differences in nozzle reaction. In sitting through a number of pre-construction conferences where the customer unfortunately didn't do their due diligence on, say, on a pre-pipe waterway, on any type of aerial device, that they finally discern and look at the manufacturer of the nozzle, of the monitor and the nozzle assembly, and determine, we don't want to use that. We want to use this because somebody saw that at a trade show. So I guess a two-part question. How much difference is there, if any, with going from manufacturer to manufacturer of the monitors, of how that impacts the nozzle reaction, assuming that it's mated with a combination nozzle? But more importantly, am I correct to say that when the unit is UL certified at any one of the manufacturers represented here, do they test it to just the NFPA minimum flow requirement of 1,000 GPM? Or if the waterway system has been advertised and has been tested for something higher than that, be it 1,250 or 1,500, whatever, does that create a different dynamic with the aerial design? And can you request that your aerial then be the water flow part of the UL test that actually be tested to what the waterway system is capable of producing?
Well, what happens with third-party testing is they recommend per NFPA to do 1,000 GPM. That's the waterway flow test. In a lot of cases, manufacturers rate their waterways higher than 1,000 GPM. Going back to your first question, a lot of the monitors, some of the bigger brand names, have similar friction loss, and a lot of your nozzle reactions are based on like an 80 PSI nozzle now. So, for instance, 1,000 GPM at 100 PSI is a 505-pound nozzle reaction. You go up to a higher 1,500 GPM with ratings, you'll get up to 606-pound nozzle reaction. So when you're doing the ladder design, you need to determine what you're going to rate your waterway at as far as flow based on what nozzle reaction. You also have to determine what positions you can put that nozzle in. I think Jennifer made the comment before about you go 90 degrees in some cases. In some cases, you're limited to 45 because the 90-degree water reaction is going to put more side load on the ladder. So you need to take that into consideration when you're doing the analysis and the engineering work. So when you get different positions, also some manufacturers have the ability to flow water above parallel to the rungs, for example. That puts a downward reaction as well on the ladder. So all those conditions are load cases that you need to consider when you're doing, in most cases, the finite element analysis, when you're doing that type of work, and when you're doing the computer work to do the analysis to make sure you meet the 2-to-1 safety factor. And then when you actually build the prototype, you'll do strain gauging to verify your FEA models. But getting back to your question about testing, third-party testing at the end of the process, just test it to the 1,000 GPM. It's up to us as a manufacturer and the engineers to make sure that you rate it at a higher rate. That one, when we do the prototype, we do the flow testing, and two, we do the engineering work to make sure we're not missing or make sure that we're maintaining the 2-to-1 safety factor based on the stress that the water reaction produces in the water flow.
No, thank you. So, Justin, have you ever had anyone where you've a customer, take one of your towers, for example, and it's fairly common, at least with some of the mid-mounted and rear-mounted platforms, that people will put two monitors in there and inadvertently spec a monitor that individually is capable of 1,000 GPM and then sometimes get duped into putting even a larger GPM capacity fog nozzle on there, thinking that the nozzle's the controlling factor when in essence it's not. It's the hydraulic limitations of the piping that was designed so that you wouldn't exceed the stresses imposed on a platform. Have you ever had during an inspection someone say, well, I want to see the unit flow X that was higher than 1,000 GPM, and how do you handle that?
Yeah, so we have max capacity testing that we do here. Just like John was saying, is the manufacturer themselves or the OEM, they will test, upwards of that safety factor, 2-to-1 or 3-to-1 that you might have depending on the aerial device. That is kind of flown. So alluding to your question of two monitors versus one monitor, it really depends on the reaction force and the angle in which you can flow both of those monitors at the same time, what the waterway diameter is sized at. I know on some of our industrial units, we go to a larger waterway to get a higher flow capacity. There's also a lot of things that come into factor with the friction loss. You know, how many elbows you have, the size of the waterway for the friction loss. The monitor itself, you know, it depends on how much you can, the vendors will supply, and that will mount up to the flange on the actual waterway itself. So if you have 1,000 GPM monitor and say you have a 1250 GPM fog nozzle, well, you're not really going to get 1250 because the monitor is only rated at 1,000. So it's almost like you're putting a 50 TK rear axle on it and you're expecting 60,000 pound tires. So the weight of the capacity is only 52,000 on the actual axle. You're not getting the 60,000 tire rating for the unit itself. So we do have some customers that do want to see a little bit higher flow. And if we can achieve it, then we will safely based on the calculations from the engineers. So.
Okay, no, thank you.
Yeah.
So I'm sorry.
I was gonna say, to elaborate a little bit on what Justin said too, NFPA, that's another standard that they designate for us. You talked about friction loss. So you can't exceed 100 PSI friction loss from the tip down to the swivel. So that's something else that we watch and test for as well. Because if you get too many bends or turns in the waterway, you're gonna end up having too high of a friction loss.
Okay, so a question particular for be it a midship mount or a rear mount, an aerial ladder, not a platform now, but a non-quint, something that doesn't have a pump, that's reliant upon another outside water source. What is, from your experience, what is the preferred way to control the water flow into the ladder pipe up to the monitor? I recognize there's at least 2 or 3 different, you know, onboard as well as off-board systems to use, but in order to reduce water hammer and the potential for damage to the waterway piping and anything else that can go wrong, Jennifer, what have you seen, or what would you suggest for folks to go do that? There is, I think, somewhat a little bit of a resurgence that people recognize. I loved it when Justin talked about a real truck company. You know, if you want a pumper, call a pumper, right? You want a truck's got to show up with a lot of tools, a lot of equipment, and some big ugly guys that are going to do damage, all right, and make sure that the fire goes out. So when you get to that kind of situation, what's the recommended mechanism that you've seen that you prefer, or from an engineering perspective, might cost some money, but is least likely to cause some damage for somebody doing something that they weren't supposed to do?
It's a good question. I haven't really run into that question before, as far as, you know, we again rate it for certain pressures, inlet pressures, and what that waterway can handle. 250 PSI are typically most what the working pressures are for anything. There's relief valves put into the system to protect it if they do something too high. But I don't know if John or Justin, if you've run across that as far as a preferred way for them to feed that. Yeah, I haven't really run across that.
Okay, John?
From my experience, if you don't have a pump feeding the aerial device, usually if it's a mid-mount type aerial feeding from the side, or if it's a rear mount, basically what you want to have, and then is like a slow close valve that's actually feeding into the aerial device. And I think Jennifer mentioned early on about water hammer and dynamic load. So we want to be careful as if you meet the requirements of NFPA as far as valve speed, as far as opening and closing, to feed that waterway, and also just as important when you shut it down.
No.
Yeah, the plumbing design really comes into a factor at that point. Typically on a no pump setup, you're generally going to have your external relief or external intake valve is kind of where you're going to control the incoming source. We have had customers that have just wanted straight pipe. We kind of caution against that. Again, when you're flowing the water, there's nothing stopping it. So if you have the tip open, or if you have a valve somewhere in between that was left open, based on your SOGs or SOPs, that water's just going to start flowing. So you got to have some way to control that water, whether it's gating it with an internal MIV, usually electric or manual. But then again, it all depends on how you have your plumbing set up and being able to pull multiple intakes. So if you have an intake on each side of the truck, you generally have an external valve, intake valve on both sides, so you don't have to shut the operations down just to hook up another source.
All right. Thank you, Justin. So now kind of going up to the tip of the aerial device or within the working confines of the platform, what type of tool and equipment allowances are determined? And when you get to the point, I've had numerous examples of people, putting a lot of different options on the device. Stokes basket box on one side, storage for ground ladders, double hook ladder on the other side, putting a bunch of stuff up at the tip, some outlets within the confines of the platform. We got a mass compartment and a small hose compartment placed for a New York hook up on the top fly section, and then we run LED lights up both sections. How do you determine what the best way to guide a customer through making sure that whatever your allowance is for the tip of the device, that they don't exceed that and it's going to be something that's safe to operate?
I guess, got me to answer? I would think that different manufacturers may do it differently. From my experiences, we have actually how different products can be designed differently up front. There's things designed in. Basic NFPA required equipment is all part of the baseline, not included in what we offer, like for additional equipment allowance. Depending on the product, we may even include other things in the original design. And then beyond that, we will have a designated allowance, whether it's 150 pounds or 300 pounds, depending on product, it can change. We work with customers up front. There is a known effective tip weight for every option that we offer. And there's dozens of different options, from rope ladders to pike poles to additional saw scabbards, hose, different options that go up on the tip of the basket or a tip of the device. And so with that additional tip weight, there's a calculator that we work with, that I've worked with customers on upfront in the process. So we know exactly what they're coming in and what equipment they have. And if they want too much, there's options that we can also work with them on, depending on what the tip load rating is of the device and what they have for water flow. So we can work with them a little bit on the different design criteria, but ultimately we have a calculator that I've used in the past to help the customer guide them in to make sure that they meet the allowances up front before we start building anything.
All right, thank you, John. Your thoughts on that, or if you find yourself in a situation where the customer working with their local salesperson is from your spec system is loaded up with a lot of stuff, and now you're in a position where you have to do something to kind of lighten up the platform or lighten up the tip. Any thoughts or recommendations as to what to do in those situations?
Well, just touching real quick on how you come up with the capacities. From an aero engineering perspective, I look at everything as a load case. So when we're doing the analysis, we can't exceed the safety factor. So when you meet with the salespeople as you're developing the product, and they want everything in the kitchen sink, so you talk with them reasonably, say, okay, what kind of equipment are we standardly going to offer here? So you take that into consideration. What's the weight of that? And also then you say, what other additional equipment allowance do we want? I usually look at it from perspective when I'm doing new product development. You kind of give the wish list to the input from the marketing and salespeople, and then you have a common sense conversation saying, okay, I can't put an 800-pound equipment allowance on this thing. So usually you end up with a 200 to 250-pound equipment allowance on a platform, maybe 150 pounds on the ladder. And then what you do, you try to put tools in the quoting tool system, or at least some notes that says, if you're selecting this equipment, we also do a weight analysis on every truck that says, okay, once you get to this point, and the customer needs to start making some decisions. I know in the past I had a customer wanted to put a winch in the platform. It was a 350-pound winch, and they insisted they needed to have it because the main reason for this product was to do winch rescue. So at that point, then you have the D-rate conversation. It doesn't happen very often, but if you have a customer to really insist on something beyond that 200 pounds or 250 or whatever the weight allowance is, you can't exceed that safety factor in the aero device. So you need to keep track of what you're putting in a platform or on the tip of a ladder to make sure not only the safety factor for stress for 2 to 1, but also so you don't tip the thing over.
Yeah.
So
Yep, very good. Best word you had, John, was common sense, which sometimes is a lost commodity.
yeah.
Justin, thoughts on that topic, and then we're going to move on to something else. But what kind of issues have you encountered with folks that want to load everything in the proverbial kitchen sink and put it up there?
Yeah, the biggest thing is just making sure that you're within that safety factor, and basically you're operating safely from the tip of the ladder, whether it's from the platform or from the tip, that you're not overextending yourself or kind of overloading yourself too. And that's why there's, if you have 1,000-pound tip load in the platform, that you're not overloading that as far as with equipment, personnel. You don't have 5 people in the bucket. And then we also consider anything that you're going to mount onto the boom itself. So when it comes to being able to design the boom and anything that's attached to it, you want to keep everything as close to that boom assembly as possible, whether you have ladders, stokes baskets, saw boxes. We're seeing air tanks now. You want to have that stuff as much as possible close to that boom and not kind of hanging out, because you're going to get a torque and a flex in your aerial device, whether it's driving down the road or it's actually in operation. So it's just being able to kind of talk to the customer and kind of saying, hey, what kind of ladder are you going to put on the outside? What kind of equipment do you want in the bucket itself? Like John was saying, if we have to, we'll derate the bucket based on everything that they have and then the lifting capacity. I know a lot of people have rope rescue type of situations where they're rappelling and they're kind of shock loading the boom. So that's never a situation that you want to get into, because those are forces that I don't think a lot of people realize. When you jump on, jump on a platform, it's not just 250 pounds that are coming down on it of the person and the equipment. It's a multiplication factor of the force that you're actually exerting on the bucket itself. So there's a lot of factors that our engineers have to go through day in, day out, making sure that we're meeting the customer's expectations while also considering that safety factor.
Thank you. So we had a couple of questions that came in from the audience. The first one was, any insights from the panel, anybody that would have a background or comment, is why the current 1901 nor the 1911 standard requires annual air testing for an air system that would be supplied up on an aerial or a platform device. Anyone on the panel have any insights as to why, for whatever reason, that particular area wasn't covered?
Not that I'm familiar with. It may have just been one of those old situations where there was breathing air one time put on it, and then they put a standard in, and it just hasn't been addressed. So it's probably something that will get addressed in the future.
Yeah, breathing air is not required. I haven't run across that either. Don't know.
Okay, all right. The second question was, I guess somebody's looking out into the future, wanted to know if there's anything on the horizon about new aerial device materials, something that we're going to build the device out of, as everyone in the audience is familiar with. I mean, we build them in aluminum using different techniques, and we build them in steel and using different things. But any insights? We'll go around the horn from starting with Jennifer. Anything that you see on the horizon that I've heard for years that somewhere, I believe it is actually being tested out. I just read a book on what goes on at Area 51, and there is some composite devices being constructed there. We just don't know about it yet. So
there's a lot of different materials, a lot of things that, of course, we've all looked into. And one of the biggest things and challenges would be some cost prohibitive. There's also temperature effects on different types of materials that have to be taken into consideration, and maybe a negative impact to that. But definitely, and weight is the other thing. So the cost, the weight, temperature effects on different materials, a lot of times bring us back to that steel, high strength steel, some aluminums. There's different materials within aluminum and steel, and but nothing on the horizon.
John, anything you're working on in the John Brady Skunk Works that you care to share?
Well, a lot of what's going on probably in the last 10, 15 years, it's not brand new, but high strength steel, 100 KSI material. Back when I started doing ladder development, you had your A500 grade Bs and Cs, which were 46 and 50,000 yield respectively. And you had to meet that 2-to-1 safety factor, which means you can load it beyond 25,000 PSI to stay within the safety factor. So in the last 10, 15 years, you heard the term high strength steel. You're seeing 100 KSI. Back in the day, 100 KSI material meant you had to preheat it before you weld it, and post-heat it. It was hard to work with. It was higher content of carbon. It was more brittle. But now there's high strength steels that are weldable. It's machinable. It's coming from the mill, 100,000 plus yield. So you're seeing some aerial devices getting lighter just because of the ability to get a higher yield steel. It's still a steel ladder, but it's not the same old steel that your father used to use, or there's some new technology or new ways of making that steel. And I think most manufacturers now are using some form of a high strength steel. You get one of two things: you either get a higher safety factor, you get a lighter ladder. In most cases, people are looking for a lighter ladder.
And it's easier to get than it used to be years ago.
Yeah, that stuff, not to get too off track, but back in the day, you had to buy a 26-ton coil of it and get one size formed out of it. So when you ordered steel, you had enough for the next 20 years of putting handrails on the base section.
Thank you, John. Justin, any comment on that?
Yeah, so we haven't really experimented with any new materials. Being a primarily just an aluminum boom construction, we have definitely dialed in our tolerances. So we are the mil spec to us is kind of where we're at, but we want to be above mil spec from our tolerances, just because of the design that we have in our boom construction. So it's we've kind of been building this type of technology, or the design that we have today, since the 60s. So something that's kind of worked for us. We really haven't experimented outside of that, just being an aluminum manufacturer.
Oh, no, thank you all. I think just to kind of round out that thought about when Jennifer mentioned several times about the weight, I just finished working with a department that was replacing still in nice shape, but a 24-year-old 100-foot rear mount platform that was a quint and had seating for 8. It was an all volunteer department. And back in the day when they bought that, it was held up with a 21,500 pound rated front axle and a 52,000 pound rear. And arguably it's overloaded because they've got about 3,200 pounds of stuff on it, all right, in excess of the NFPA minimum of 2,500. And in working with them on their new device, which is current day version of what they bought, that unit's now going to have a 24,000 pound front axle and a 62,000 pound rear. We've just about maxed out the capabilities of what the axle manufacturers can provide. And, that's just the way the world really goes to what Jennifer, John, and Justin were just talking about, is that the rigs are physically getting larger and heavier, and anything that's on a tandem axle by its nature, it's the heaviest unit that the fire department has in the fleet. And in some cases, it's arguably, they may have a fire station big enough to get it into. It may be tough getting that around town. We want to end up with the last question. So with certain types of devices, when he talked about, John's referenced several times about this 2-to-1 stability factor. So John, if you wouldn't mind maybe just talking to that point, and then we'll go around the horn and just say what type of aerial devices require counterbalance weight to either help you from an engineering standpoint to meet that 2-to-1 safety factor, or in some cases, I think relevant to mid-mount devices in particular, that require counterbalance weight, so you're offsetting weight on the front axle so we can hold it up with a 23 or a 24,000 pound rear. So John, we'll start with you and then we'll go around the horn on that.
Okay, as far as counterweight goes, a lot of aerial devices do not require counterweight. To my experience, if you need counterweight, one of two things is going on. You need counterweight for stability. So when third parties doing their 1.5 load tip test, and they're actually doing the stability test rotating aerial device, and it doesn't remain stable, then counterweight is added to give you more ballast for the stability test. And to your point, Tom, you put the truck over the scales and your 24,000 pound axle fully loaded is at 24.4 now. What the remedy to that is you go as far to the rear end of the truck as you can, you hang some counterweight off of it and release some load off the front axle. You seem to be careful there because all the weight you're taking off the front axle, you're putting more than that on the rear axle when you're hanging it off the rear. So usually counterweight is one of those two events. You need it for stability, or you're trying to move some weight around on the truck to relieve an axle.
Mhm.
All right, thanks, Jennifer. Your thoughts on that?
Sure. I get one thing that comes to mind is, I know you were saying 2-to-1 safety factor. For stability, it's NFPA is 1.5 to 1. Structure is 2 to 1. Those are the minimums for NFPA. And I get a lot from customers where they get the two confused, and they're really not. They're very different. A 1.5 to 1 stability safety factor is very different than we're talking a structural safety factor, and both things have to be taken into consideration when you're designing and testing a device. So just want to put that out there a little bit. Everything, and when manufacturers advertise safety factors, it's usually referring always to the structural safety factor, 2 to 1, 2.5, 3 to 1. But stability is a little different, where you can make your truck stable if it has the right dependable weight on it. And dependable weight meaning the empty weight of the truck as it sits, and being able to resist that overturning moment of that load at the tip that you're adding onto it. You have to keep a 1.5 to 1 of that rated load is, to be able to keep that up in the air. But the structure at times can be significantly more than that. So it's a little bit different, and I wanted to just point that out because I do get a lot of confusion from customers when they talk safety factors, whether it's structure or stability. But it is two different things when we're talking about it. So I don't know if John or Justin, you want to elaborate on that at all, but
Jennifer, before we roll down to Justin, you made a comment on a term that I find very intriguing. That's one of the first times I heard it referred to as dependable weight. So could you define that? If we think about the structure of the fire truck, the cab, the body, the torque box, the weight of the aerial device, and let's say in this case we got a fire pump on it. So we have a fire pump and a 300-gallon water tank, and I, as the fire chief, I'm going to throw some hose and other equipment on it. So what is referred to from a design standpoint as dependable weight versus weight that the fire department or somebody's going to add later on?
So a dependable weight is basically the truck, your finished truck, with every piece of loose equipment off of it. So no people, no hose, no water, no foam, empty. If you can take it off the truck, it's coming off the truck. And that's how we, as manufacturers, have to test stability on that truck. So that truck has to meet a 1.5 to 1 safety factor with it completely empty, as built before it leaves the factory. And every single truck is tested to that. So a dependable weight is just that minimum weight of what a truck for that certain product and rated loads have to meet that 1.5 to 1 stability safety factor.
Okay, thank you. So Justin, thoughts on counterbalance weight, and then again, because you get involved with a lot of final product inspections by the customers, have you ever had a customer say, I know the platform's rated for 1,000 pounds. I want to see the test. I know you people did it. You maybe send me a great video or some photos, but I while we're here for the day and a half, I'd like to see it tested to that 1,500 pounds. How do you handle that?
Yeah, so we actually have some customers that want to witness testing. We'll set it up here on site. We do vigorous testing, so we do our own testing, but it also gets third-party tested as well, whether that's UL testing or another third party for an FTA. So yeah, if they want to witness, we have customers at final inspection that want to witness the high flow as well. They want to say, hey, how much capacity can I get out of this, or can I witness all of the various testing? So we go through all of those requests. When it comes to counterbalance weight, the truck itself, just like John said, if you have to add weight to the truck, something else is kind of going on. But a lot of times what you'll see is, like John was saying, is shorter wheelbases, you're going to put a lot more weight on the rear axle than you are in the front. But if you have a longer wheelbase, that weight is now going to be distributed more towards the front. So it's definitely a delicate balance of distributing that weight. A lot of times what we're seeing is customers don't know exactly where they're going to place their equipment and don't know the exact amount of weight that they're going to have. Now, there are some customers that they do go to that nth degree and saying, I want this saw located here and in this compartment. So we can actually calculate the weight that's going to be in each compartment and let them know, hey, this is where it's at. But if not, we have to go by NFPA and say, hey, NFPA is saying 3,000 pounds. If you put more than that on it, you should have told us. You know what I mean? You got to divulge that information up front because we can't read your mind on how much equipment you're going to put on it. So if we're expecting 3,000 and you're expecting 8,000, that's a huge difference, and that's only going to wear on your components over time with the shocks and the springs and the axles and the bearings. All of that's going to be affected over time when you're talking about weight. The only times you really have to worry about counterbalancing is if you're removing something. So if you don't have a tank or a pump, you got to put that weight back in somewhere because that weight is already being calculated as a complete truck. So if you're removing very heavy components, we got to figure out where that weight's going to go back in there because it is a delicate balance. You know, from the materials that we use to whether it's a steel boom to an aluminum boom to a stainless body to an aluminum body, it all plays into effect not only on the weight axles but counterbalancing of the actual truck itself. So, and the torque tubes that we use and the thickness of materials. So there is extremely numerous amount of factors and variables with all these aerial devices that, you know, it's a delicate balance no matter what you do for the design.
Yeah.
Hey, Tom, just maybe 3 minutes left. So kind of final questions or comments. We can go a little bit more if we have to, but let's go with 3 more minutes.
Okay, all right. Thank you, Kevin. All right, well, let's just go around the horn. Again, starting out, first, we'd like to very much thank Jennifer, John, and Justin for your time, your insights. Very, very valuable. It's rare that a fire truck buying audience gets to meet the people behind the scenes that are actually doing the engineering. Even when we come to the point of pre-construction, sometimes you're well hidden. So we certainly appreciate your insights. Jennifer, any final thoughts or comments?
Just a little bit on the stability and what we said before. One thing, every single truck that comes through a manufacturer's door, we're looking at everyone up front. We do weight analysis, we do stability analysis, we do the tip load calculator that I mentioned, and that's done on every single truck and then tested on every single truck. So very custom. It is definitely, our industry is very custom with how we do things and how we build trucks. I like to think every little truck is a little project. So.
All right, thank you, John.
The presentation before the arrow, Mike Wilbur made the comment about weigh your truck, weigh your truck, weigh your truck. My comment to that, and we talked about a little bit here, is NFPA allows on an aerial device 2,500 pounds of equipment. In the 30-some years I've been doing this, I can probably count on one hand the times I saw a spec where a customer said, yep, I'm going to carry more than 2,500 pounds of equipment. I'm going to carry 4,000 or whatever it is. So I guess my only comment is if you're speccing out a device, aerial or not, and you know you're going to be exceeding that NFPA equipment, Jennifer made the comment, a weight analysis is done on every truck and we're doing the bid process. At that point, you're assuming the 2,500 pounds of equipment. You go through the whole process, you build the truck, you do all the testing, you deliver the truck, you get the phone call, my front axle or my rear axle is overweight, and you find out they have 5,000 pounds worth of equipment on the truck. That's something that needs to be talked about in the front of the process, because at the end of the process, when your truck's overweight, that's a problem nobody ever wants to have.
Thank you, John. Justin, final thoughts?
Yeah, just mainly just working with your sales rep or your OEM, working with your close contact, making sure that you're speccing the right truck for your area. Just because New York City, Boston, the big fire departments are doing it, it's not really going to work in your area. So know your angles of departure, know your angles of approach, whether you got hills, it's flat. So there's a lot of variables that go into that when you're speccing your engines. You're talking about a very heavy truck. So you got to know your weight ratings on your bridges, your overall heights. Some of these rear mount aerials, they can reach up to 12 feet, you know, in overall height, 11'6". So there's a lot of variables that you have to look at your area and what's going to work best for you. Is a 75 footer going to work for me, or do I need to go up to that 100 footer? I mean, there's a lot of different factors that go into play. You reach out to your representative, you get kind of information from the interweb, but really do your homework, ask those important questions, say, hey, what have you seen in the industry? What's going on? I can consider that, but this is what I have in my area. What do you recommend? So definitely bring those questions to the table, and that's what we're here to answer. Because like Jennifer was saying, these are all custom trucks. We're seeing a lot of stuff, and each one is definitely seen as its own individual project, and it's kind of its own baby to all these fire departments. So,
Right.
that's what I have.
Well, thank you. So thank you very much to the panel. So Jennifer, John, Justin, appreciate your input, your insights this afternoon. Thank you so much. Kevin, back to you.
Thank you all. Great,
Thank you.
great job.